Hello, Lynchburg City students. I'm back at it again today. I'm Tristan Brown. I'm here today to help with you with some more math SAT prep. We've done a fair amount of these videos now, so I thought we might take it up a notch, change it up a little bit. All the questions we've done beforehand, if you remember from the intro video, that was a guide for the calculator section. And today, I wanted to take a question from the non-calculator section, and going forward, I want to certainly integrate more of those problems into the videos and what we do. So this section, and anytime you see this in the corner, it's going to mean the problem in the video that you're watching is for a problem in the no calculator section. It's a very similar section. Topically, they're the same for primary sections that are in the calculator section. The difference is there's a focus on this passport to advanced mathematics section, whereas the focus of the calculator section is the heart of algebra. There's still going to be questions from both. One thing I will say, in all the questions I've looked at thus far for the no calculator section, there have been none of the probability, or not probability, but problem solving and data analysis problems in the no calculator section. And so there's a couple different topics, and so aside from that, there are a couple different topics within these sections that aren't covered in the no calculator section, most notably in the additional topics, which, if you remember from all the videos thus far in the calculator section, they're all either geometry or trigonometry based. In this section here, they do a lot with the imaginary number I, and we'll have several videos in the coming days that focus on I, so you are adequately prepared to deal with that if you're not already. That being said, I just want to get that out of the way before we went any further. So now let's get into this problem. You can see it's green today, so I want to start with an easy problem from the section, not get too difficult too fast, because some of these can be very tricky, and we'll even get a little bit of trickery in our problem today. But let's get through the problem and then you'll see what that is. So the problem says if a squared plus 14a equals 51 and a is greater than 0, what is the value of a plus 7? Before I go any further to solving this, remember, this is a video. If I ever start going too fast or you just miss something I do, you can pause it or rewind or do whatever you need to. Once I get everything written out, if you want to pause it and try to solve it yourself before you watch me do it, do whatever is best for you. It's a video. You can watch this as many times as you need to, so you're best prepared and have complete mastery over this type of problem. So that being said, let me write this out just in case the notation's a little confusing. It says if a squared plus 14a equals 51 with the condition that a is greater than 0, what is a plus 7? So first, if you look at this, this looks similar to what we do with a lot in algebra. We have an a squared term, an a term, and a term with no variable. So that's very similar to us. The difference is we have this little equal sign here. So what we're going to do is subtract 51 so that all of our terms are on one side of the equation. So we're going to have a squared plus 14a minus, because we're subtracting 51, equals 0, which is what we're left with now. So now you see this, and usually what we would do with something like this is we factor it. However, this 51, it's a little odd, isn't it? I know that's not a very natural number. Well, it is a natural number systematically, but it's not a number we typically deal with. It's not a very nice number like 16 or 9. It's not a square or anything like that. It's something we see in our multiplication tables. So you might think, it only factors as 51 and 1, which of course any combination of 51 and 1, whether positive or negative, none of that equals 14. So that can't be right. So if you didn't know that and you were just lost, you could put this into the quadratic equation and you would get the right answers, assuming you did all the algebra in that right. But this 51 is actually factorable by 17 and 3. And so we're going to use those as our factors. This is an odd one. I don't know why, when I was in elementary school, my 4th grade math teacher found it fascinating. 17 times 3 was 51. So I actually just had that one memorized. But I'd say for most people, that's not the case. But now that we know it does factor like that, Let's write this like we were factoring. I'm just going to start this off. We know we're going to have two binomials. They're both going to start with A, since our coefficient's 1. A, and we're going to close our parentheses, and eventually altogether that equals 0. Now what we do, we look at this. It's a negative sign, which means we're going to have 1 plus and 1 minus, and since our coefficient's only 1, we can just go ahead and place them whichever way you like. My plus here, my minus here. And now that we have that, and our coefficient's 1 here, what we can do is look at this sign, which is a plus, and what we say is, of our two factors, since this is a positive 14, our bigger factor has to go with the plus sign, and our bigger factor in this case is 17, and then 3 goes here. And then hopefully you know A plus 17, we just set that equal to 0. And we set A plus 3 equal to 0, or A minus 3, excuse me. Well, A minus, all sorts of messed up today. It was 0. Then we just solve A equals negative 17 and A equals 3. So now we have these, which is typically what your answer would be. However, back to the beginning, we have this condition that A has to be greater than 0, which means that this one is eliminated. And we just come back, circle back to this one as our answer for A. So then, after we do that, we have a very simple thing to do. Since A equals 3, that's what A plus 7 is. So we just plug in 3 for A. So we come back here and we say 3 plus 7. And then I'm not going to write this in 2 steps because this is fairly common and easy. But 3 plus 7 equals 10. So that should be our solution if I did all of that right. Let me see, where's my mouse? There we go. And it is, A plus 7 equals 10. And of course, I did go through a lot of this, but like we said, we subtracted 51 from our initial equation, so we had everything on one side, and it was factorable. If it wasn't factorable, of course, we could have used the quadratic equation to get an answer. Typically, you use that if it doesn't come out even. Anytime we're going to have integers, typically you're always going to be able to factor it if our solutions come out as integers, as opposed to fractions or any sort of decimal. And then we used our A is greater than 0 to determine that A had to equal 3, and we plugged that into A plus 7, which gave us 10. However, once you got to the 3 and the negative 17, if you weren't sure about that, what you could have done is plug 3 back into the equation, A squared plus 14A minus 51. And if you put that all together and it equals 0, you would have known you had the correct answer. So that's just an extra thing to do if you want to check yourself. While you're doing these problems, it can be easy to get lost. Just make a minor mistake in the algebra and have something completely different than what the answer actually is. Even though you went through all you knew what to do, you just made a minor algebra mistake. So that's always a good thing to check for. So just keep that in mind as you're going through your problems on the SAT. Of course, don't take too much time on any given problem, but I just thought I would give you that little piece of advice. We'll have more of these problems to come in this no calculator section. I know this problem might have been a little bit trickier, even though it said it was an easy problem. And they do get more difficult, but we'll go through some of those as well to make sure you're prepared. I hope you guys have a great rest of your day. Thank you for watching, and I will see you with the next video.